Right, let's have a go at this question. A spherical balloon is inflated with air at a rate of 200 centimeter cube per minute. At what rate is the radius increasing when the radius is 8? Now, first of all, when we're doing this, it's talking about sphere, and it's talking about the rate at which it's increasing. Okay, that's the volume. There's the hint. So first of all, dV is being inflated. Rate is always respect to t. Remember that. So dV dt is 200, and it wants to find out the rate at which the radius is increasing. dr dt, that's the rate at which the radius is increasing at the point when r is equal to 8. Okay, so we need to find dr dt. We've been given dv dt. So on the bottom we have dt, on the top we want dr, we got dv. So what we do is we multiply that by dv, so they will cancel, and introduce dr. This is chain rule, which we have done, and it's going to come big style in this topic, okay, because it's rate of change. We're measuring rate of change. Now, dV, dr, or dr, dv, how are they rated? Well, they're related by the volume of a sphere. Now, you should know that the volume of a sphere is 4/3 pi r cubed. Okay. Now, sometimes it might give you that in the question. Other times you'll have to just memorize that. So, if I differentiate this respect to r, take the power down, take 1 off the power. So I took the 3 down, multiplied that by 3, so the third cancelled, and I took 1 off the 3, which becomes 2. So I got dV dr equals 4 pi r squared. So now I want dr dv. So what you can simply do is, rather than rearranging it, take the reciprocal. So dr dv will be just 1 over 4 pi r squared. Now, it wants to know what is the rate of increase at the point when radius is 8. So the rate at which the radius is increasing is going to be, well, first of all, we know that the rate at which the volume is increasing is 200 centimeter cube, and the rate at which the radius is increasing is in respect to the radius, so that's going to be 1 over 4 pi, and this time with respect to the radius you sub in radius is 8 squared. So if you just plug that now in your calculator, which I'm going to do, you'll get 200 over 4 times 64 pi, so you're going to get 25 over 32 pi. You can leave it like that. That's an exact number, so I'm happy with that. And if you want to put the unit rate at which the radius is, that is the radius, this is centimeters per minute. Okay.